I want to do a fraction review today just to get you ready before we go on to what's coming next in fractions. It's going to be very basic. You might want to stop and rewind it a couple times and then try some on your own that are modeled just like the practice problems I provide. And what do we know about fractions? Fractions are equal pieces of a whole or a group. And right now we're just talking about the wholes. Fractions. 2/3 is a fraction. A fraction has a top numerator, a bottom denominator. The bottom denominator tells me how many equal pieces are in the whole. The key word is equal. So my whole is going to be a fraction bar, and it's going to have 3 pieces. My top numerator tells me I'm referencing 2 of those. So this fraction bar shows me 2/3. So if I'm going to do something as simple as 2/3 plus another 2/3. So now I'm adding 2/3 plus 2/3. Because I have a common or the same denominator, it makes it easy. So I have 2/3, then I'm going to add another 2/3 to that. So here's my fraction bar. And I'm going to add another 2/3. My pieces are all the same size, they're thirds. And then when I add up how many of those I have 1, 2, 3, 4. I have 4/3. I'm looking at my fraction. My bottom number tells me 3 pieces for the whole. My top numerator tells me how many of those I'm referencing. I have 4. But I only need 3 pieces to make a whole. So I have more than I need to make a whole. When my top numerator is bigger than my bottom denominator, that's a fraction greater than a whole. And what does this look like? Here's my 2/3 and my 2/3, but let's make some empty fraction bars again in thirds. And I'm going to fill in 4 of them. 1, 2, 3, 4. I filled in 1 whole bar and 1 piece left, that's a third. So 4/3, which is a fraction greater than a whole, is equal to 4/3 is equal to 1 whole bar, and 1/3. 1 and 1/3 is called a mixed number. It's a mixed number because it has wholes, which are the numbers we've been talking about ever since you started school. All the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 past a million, those are all whole numbers. Then we added fractions, which are pieces of the whole. So this is a mixed number, 1 whole and 1/3. I went from a fraction greater than a whole with my top numerator bigger than my bottom denominator to a mixed number. That's called simplifying it. That's making it easier to read. I'm going to try another one of those fractions greater than a whole and turn it into a mixed number. I will do 7/3. 7/3 is a fraction greater than a whole because my bottom number tells me I need 3 pieces to make a whole. Because whenever my top numerator is the same as my bottom denominator, that equals 1 whole. I could have 67 67ths. Doesn't matter. As long as my numerator and denominator are the same, I have all the pieces that equal 1 whole. So it's 1. So 7/3. That means I need 3 pieces to make a whole. And I have more than 3. In fact, I have quite a bit more than 3. I could draw my fraction bars because I need 3 pieces to make a whole. And I have 7. 1, 2, 3. Oh, gotta make another one. 4, 5, 6. Ooh, and I have to make a third one. 7. My pieces are thirds. I have 7. So 7/3 equals 1, 2 wholes, and there's one piece left, and those are thirds. I could draw fraction bars, or since I know math is patterns, and I know this line tells me to divide, I can take how many 3's right here are in 7? 7 divided by 3. How many 3's are in 7? 2. 2 times 3 are 6. Subtract. I have 1 left. 7 divided by 3 is 2, remainder 1. 2 wholes, and my remainder's up here for 1/3. One piece remains, it's a third. So I could draw the fraction bars for the visual, or I could do the division, because that's what I am actually doing. I'm dividing it into groups of 3. I have 16/5, which is a fraction greater than a whole. That tells me I only need 5 pieces to make a whole. That means how many 5's are in 16? Because for every 5, that's 1 whole piece. So that's the same as 16 divided by 5. How many 5's in 16? 3. 3 times 5 are 15. Subtract 1, remainder 1. That means I can make 3 wholes, and I have 1 piece left, and it's a fifth. 3 1/5. If you're not sure about that, we can do the fraction bars. 5 pieces for a whole, so my fraction bars are 1, 2, 3, 5. I'm probably going to need more than this. Well, let's start counting. 16, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So what do I have? I have 1 whole, 2 whole, 3 wholes, 3, and 1 piece remains, and it's a fifth. 3 1/5, or I can divide. How many 5's in 16? 3, remainder 1. 3, 1 remains, and it's a fifth. Everything's related in math. "14/3. That means how many groups of 3 can I make out of 14? That sounds to me like division. 14 divided by 3. 3 times what gets me close? 4. 4 times 3 are 12. Subtract remainder 2. That means I can make 4 whole groups. There's 2 left. 2's my remainder. My pieces are thirds. 4 2/3. Fraction greater than a whole, a mixed number. And how does that work in the opposite direction? Because remember, inverse, to check our multiplication and division, we do inverse. Same thing with the addition and subtraction. So we're going to go back and forth between fractions greater than a whole to a mixed number. So we saw how to change a fraction greater than a whole, something that has a higher numerator, which means more pieces than I need to make a whole because my numerator is larger than my denominator. Now we're going to go to a mixed number. Let's do 2 3/4. That means I have 2 wholes and 3/4. But I'm going to turn that into a fraction greater than a whole. A fraction greater than a whole means my numerator is going to be larger. So that means I have 2 whole pieces. And what size are they? Fourths. I will draw the picture first, and then I bet you can figure out what the pattern is in this. So 2 wholes, and they are in fourths. So there's 1 whole, 2 wholes. Because remember, 4 pieces make a whole. If my denominator's 4, my numerator's 4. So there's 2 wholes plus 3/4. Now I'm just going to count the fourths. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 fourths. What does that mean? 2 wholes would be the same thing as if I did 4 fourths plus 4 fourths plus 3 fourths. 4, 8, 11 fourths. I could do it that way. Or I could do 2 times 4. There's 4 here, there's 4 here. 2 times 4 plus my 3 equals 2 times 4 is 8 plus 3 is 11. 2 times 4 plus 3 is 11. Pretty cool how that works. Let's try another one. Three and a third, which is a mixed number. It has wholes and it has fractional pieces. I'm going to turn that into a fraction greater than a whole. So what do I know about 3 and a third? I need 3 pieces to make a whole, and I have 3 wholes. So if I were to do that as repeated addition, and we know repeated addition is multiplication, which we'll show you how to do that in a minute. So 3 wholes is 3/3 because that's 1 whole, plus another whole, plus another whole, so that's 1 plus 1 plus 1 to make my 3, and then my 1/3, 3, 6, 9, 10. 10 thirds. 10 thirds. I could show that visually as a fraction bar. 3 pieces to make a whole. Here's my 3 wholes. And then 1/3. So then if I count all my thirds, I have 3, 6, 9, 10 thirds. Or 3 groups of 3, 3 groups of 3, 3 groups of 3, plus my 1 equals 3 times 3 is 9 plus 1 is 10. 10 thirds. 3 groups of 3 plus 1. 3 times 3 is 9 plus 1 is 10. That's pretty cool how that works. I'm going to do addition with mixed numbers. These are mixed numbers, 2 and 3/4 plus 3 and 2/4. When you add mixed numbers, you start just like you're adding. You would start with the ones, then the tens, then the hundreds. We start with the fractions, then the wholes. So my bottom denominator is common. It's the same. It's fourths. Then I'm going to add my numerator. I have 3 pieces plus 2 more. 5/4. Oh, wait a minute. We just talked about that number when my top numerator is bigger than my bottom denominator. Fraction greater than a whole. So 5/4 I know is, how many 4s are in 5? 1 and 1 left. 5 divided by 4 is 1. Remainder 1. So 5/4 is 1 and 1/4. So I can cross this out and make it 1/4 and put my 1 up here with my whole numbers. Then I have 1 plus 2 are 3 plus 3 is 6. So my answer is 6 and 1/4. We'll try one more of those. Three and 4/5 plus 2 3/5. You're going to add your fractional pieces first. 5 pieces to make a whole. My bottom denominator tells me 5. I add my numerator. 4 plus 3 are 7. 7/5. Once again, a fraction greater than a whole. I know I only need 5 pieces, and I have 7. How many 5s are in 7? 1. 1 times 5 are 5. Subtract, and I have 2 left. 1, remainder 2. So 7/5 is the same thing as 1 2/5. So I take my 7/5, here's my 2/5, and I add my 1 to the whole numbers. 3 plus 1 are 4, plus 2 more are 6. My answer is 6 2/5. Now we're going to do the inverse or the opposite of addition, and we're going to subtract. I'm going to subtract 7 1/4 minus 2 3/4. Same thing, we have to start with our fractional pieces. I have 1/4, and I want to take 3/4 away from it. It's like trying to subtract 3 from 1. You can't do that. So I need some more fractional pieces. And just like when we do whole number subtraction, we regroup. So we go over to the whole. That's 7 wholes. I'm going to take 1 away, make it 6. And I'm going to add 1 whole to this 1/4. And what do I know? If there's 4 pieces to make a whole, 1 whole is 4. So I'm going to add 4 plus 4/4 because that's 1 whole. 1/4 plus 4/4 equals 5/4. 5/4 minus 3 are 2/4. 6 minus 2 are 4. 4 2/4. I had to get some more fractional pieces, so I took 1 whole, and I know top number, bottom number, numerator, denominator are the same. That's 1 whole. So my 1/4 plus my whole, 4/4 equals 5/4. Let's try one more of those. Ooh, I'm making this one a little tricky. I have 6 minus 3 1/3. I start with my fractional pieces. I don't have any fractional pieces on the top. I just have 6 as a whole number. But I need some thirds. So I'm going to go from my whole number as a 6. I'm going to make it a 5. And I'm going to take my whole and put it over in thirds. And because my bottom denominator is 3, it tells me I need 3 pieces to make a whole. So I'm taking 1 whole, and that's 3/3. Now I can subtract. 3/3 minus 1/3, 2/3, 5 minus 3 are 2. 2 2/3. The more you do something, the easier it gets. You start seeing patterns in numbers and how everything is related, how inverses work back and forth. Let's go 7 2/5 minus 3 4/5. 7 2/5 minus 3 4/5. Again, I start with my fractional pieces. I have 2, and I want to subtract 4 from that. I know I can't do that, so I need some more fifths. I'm going to go over to my whole numbers and make it a 6. So I'm going to add a whole over here. My bottom denominator is 5. It tells me 5 pieces to make a whole. So I'm going to add my whole onto the 2/5. 2/5 plus 5/5 equals 7/5. 7/5 minus 4/5. 3/5. 6 minus 3 are 3. And you might have seen me do plus 5 And you'll get to the point where you might not need to do that plus 5 and just know, oh, it's 5 pieces in the whole. I'm going to add 5 to the 2, and you could cross that out and make it a 7 and not have to do all this work. You'll find ways that help you make little shortcuts after you figure out how that works, how the patterns come into play. And once you realize it, it will make it so quick, so easy, and lead to bigger and better things. So I hope that helped you a little bit on fraction review.